Third problem related to intensity of sound. Sound wave traveling in 20 degrees Celsius air has a pressure amplitude of 0.5 Pascal. If the density of air is 1.20 kilogram per cubic meter, what is the intensity of the wave in watts per meter squared? So, the first step of the problem is to identify the given variables. For the temperature of the air, 20 degrees Celsius. For the pressure amplitude, the given is 0.5 Pascal. And the density of air at 20 degrees Celsius is 1.20 kilogram per cubic meter. Therefore, our required answer should be the intensity of wave in watt per meter squared. So, the first step is to calculate the speed of the sound at a given temperature. So, we will use the equation speed of sound is equal to 331 meters per second plus the product of 0.6 meter per second per Celsius times the given temperature. So all we have to do is to plug in the 20 degrees Celsius in the formula. Okay, when we multiply 0.6 times 20, the answer is 12 meter per second. And we add 12 meter per second to the speed of sound at 0 degrees Celsius, which is 331 meters per second. Our final answer for the speed of sound at 20 degrees Celsius is 343 meters per second. Now that we have the speed of sound in the given temperature, we can now proceed to our second step, which is to calculate the intensity of the wavelength. Now, the equation that will be utilized to solve the problem is I, or the intensity of sound, is equal to the change in pressure squared divided by the product of 2 times the density of air times the speed of the sound. Okay, so we will plug in all the variables, substituting all the variables. For pressure amplitude, we have 0.5 Pascal. For the density, we have 1.20 kilogram per cubic meter. And for the speed of sound at 20 degrees Celsius, our computed value is 343 meters per second. Okay, so we will perform the operations given in the equation. So first, we get the square of 0.5. The square root of 0.5 is 0.25. Next step is to get the product of all these variables. 2 times 1.20 times 343. The product is 823.2. And our last step is to divide 0.25 divided by 823.2. And our answer, after dividing the variables, we have 3.036929052 times 10 raised to negative 4 watt per meter squared. So, we need to round up our final answer into 2 decimal places. Therefore, our final answer for the intensity of wave is 3.04 times 10 raised to negative 4 watt per square meter. That is the intensity of the wave.